Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hello and welcome everyone. Welcome to the day 18 of CodeCamp. Can I get a confirmation whether my voice is clearly audible as well as I'm visible properly or not? Hello, hi Naman. Hi, KDC Educational Institute. Okay, thank you for the confirmation, Naman. Okay, so those of you who attended my previous stream, were you guys able to solve the last question which I gave you for the practice? Yes or no in the chat box? Okay, not attended. Yeah, greedy session was awesome. Thank you, Arindam, if you enjoyed the session. Okay, unfortunately, I missed previous session. Is that available in channels playlist? Yes, all the sessions will be available. There is a playlist available on the channel itself. You can watch down uh, all the previous session will be available over there. Okay, so don't worry about that thing. So, are you guys excited for today's session? So in today's session, I'll be covering divide and conquer strategies. I'll be explaining you how to study this entire topic and how to practice these questions. Okay, the questions which are under divide and conquer strategy. A DFS of graph can I get? Okay, so graph session will be scheduled. I mean, the questions based on a graph will be uh, taken in the upcoming sessions. And previously, there was a session on graph as well. Okay, you can watch that video as well. Okay, so we'll be starting the session. Just give me 2 to 3 minutes more, and we'll be beginning the session. Okay, till then, if you have any kind of doubt regarding anything, you can write down in the chat box. We'll have a discussion till then, so that everyone who is willing to join the session, they can join the session and get the best out of it, right? So I would like to know about the audience, like how many of you are working professionals and how many of you are students. Can I just quickly get the idea about the audience that we have today? So, how many of you are freshers and how many of you are working professionals? What kind of audience do we have today? I'm final year student. Okay, so and doing on internship. Okay, working in MNC as iOS developer. Okay, final year students. Okay, that's really great. So basically, I can see a lot of you are students who are in final year, and uh, some of you are already working professionals. That's really great. Okay, so without any delay, let's start the session. Just give me a minute and we'll begin. So, how many of you know about divide and conquer? What do you think, and what understanding do you have by the term divide and conquer? If you focus on the name itself, you will be able to understand, because the words which are present inside divide and conquer, they justify themselves, right? Divide means you need to divide something, and conquer means you need to solve it, or you need to work on it, right? So tackling that other divided part means divide and conquer. Is it so? Yes or no in the chat box? Partition and make an order that merge again like quick sort. Okay, great. So just give me a minute. Let me share my screen. Dividing the problem into smaller sub problems and solve them like merge sort. Okay. Okay. Is my screen visible? Okay. I guess my screen is visible to everyone. Okay. So I got answer from everyone that dividing the problem into sub problem and tackling the other half. That's completely fine. Okay. So I can see everyone knows what divide and conquer is basically. So inside divide and conquer, what different kinds of algorithms are available? Okay. So this strategy, let's say you have a problem statement. Just give me a minute. I don't know why this is not working. Okay. So basically, divide and conquer strategy. So how does this strategy work, and how you need to like, let's say if any problem is given to you, then how will you apply this divide and conquer strategy to get a finalized solution? Okay. So let's say we have a problem given to us. Okay, I'm taking the most common problem. I mean, the most real life based problem. Let's say we have a dictionary. Okay, right? Everyone knows how to use a dictionary, right? So basically, inside a dictionary, let's say you were asked to find a word that goes by, let's say, GFG's humble towards the students. Okay, thank you, Aditya. If you feel GFG is humble towards the students, you're welcome. I mean, so dictionary. Inside dictionary, let's say you are supposed to find a word that goes laptop. Okay, you need to look for this word and you need to find the meaning of it. So how will you start searching inside the dictionary, right? We know inside the dictionary all the words from A to Z are being present. Like the first page will contain all the words that starts with the alphabet A, then the next one will contain B, C. Basically alphabetical order is being maintained inside dictionary. One of the approach which you can follow in order to find or look for a word is that one by one you will go through all the pages. Page 1 you will look whether laptop is present, then you will look in the page number 2, page number 3, and so on till, let's say, page number n. On nth page number you encountered that all the words present are starting with the alphabet L. So now this is the page where you will be looking for the word laptop, right? So this is a process in which you can sequentially go through each and every page and look for the key word which you are looking for. So this technique basically was taught to us. We are already aware about this technique, and we used to follow the same technique when we were in school, right? basically when we were in school, we were not at all aware that this technique is called linear search algorithm, right? Were we aware about this algorithm when we were using this searching pattern? Were you guys aware about this algorithm or the name of this algorithm? No, we were not at all aware, right? Because till then we were not aware about computer science. So basically, inside computer science, each and every technique, or you can say each and every algorithm, basically has somewhat relation with solving real world problems. Okay, so this dictionary problem is a real world problem, right? You look for the word, you want to search for a word, you can follow this sequential process, that is basically apply a linear search algorithm. Now what can be the other approach? What do you think, what can be the other approach to handle this part? How to search for a word in the dictionary? Anyone? So basically what I can do, inside the dictionary, I know that all the words will be arranged in alphabetical order. So what I can do, I can directly go to the middle page, okay? And let's say middle page uh, says all the letters or all the words start with the letter P. So we are sure that after P and in the range P to Z, we are not going to find any word that is going to be equal to L. Is it so? No. Basically, if I start from A, if I encounter the right portion, if I encounter the left portion of this dictionary, all the pages on the left hand side of this P will not contain any of the word that starts with the alphabet L, because in the alphabetical order, L occurs after P. Okay, basically it occurs before P, not after P. Okay, sorry, I made a mistake. So basically, the right hand part can be discarded because in the alphabetical order, we know that L occurs before P. L, M, N, O, and P, right? So basically, L will be present somewhere in this pages, starting from A and ending to P. So I will be looking for the word laptop in the left partition, in the left part. So basically I discarded the entire right portion. So half of my work, half of my energy will be saved because I don't need to look in the right portion. So I'll be looking in this part in which all the words present are in the range A to B. So now again I'll do the same process, and luckily let's say you encountered the page that says all the letters or all the words start with the letter L. So now this is the page. So over here you will not do anything. You will not look in the left partition or you will not look in the right partition. You will simply focus on the bunch of these pages that contains all the words that start with the letter L. So in this process, what you did, what was the process? So let's say this was the entire dictionary, right? This was a very huge problem. Yes, exactly, Pratik. This is what we call it as binary search. The dictionary was an entire problem, right? So what I did, I divided this problem into two different halves. That is left side of the dictionary, LD1, and the right side of this dictionary. So now I just compared whether my key will be present in right side or in left side. So basically, based on the condition, I encountered that my key will be present in the left dictionary. So now again, this is one of my sub problem, but now I will look at it as an entire problem. So again, I will divide it into two different parts, and I will call it as LD11 and LD right right partition of this part, right? So now again, what I'll be doing, I'll be looking whether my key, which I'm looking for, will be present in this right partition or in the left partition, right? So basically, I'll be able to know that whether I should discard this left partition or I should discard this right partition. So basically, what you will be doing in divide and conquer, you will be given a problem and you will be looking for the solution in the sub problems. You will discard the other part, or you will be discarding the right portion or the left portion, and you will be looking in the direction where there is a hope of finding the solution. So that is how divide and conquer strategies work. So there are many sorting algorithms as well. If I give you an idea about the sorting algorithm, so basically this idea is called as binary search, and this technique was also taught to us when we were in school, but over back then we were not aware about this algorithm, right? Because we were not taught that this is called binary search algorithm. So there are many different sorting algorithms as well. Let's say if I give you an idea about merge sort, how do you sort the array using merge sort algorithm? FCFS, LIFO. So basically, let me give you an idea about a sorting algorithm that uses divide and conquer strategy. So let's say we were given an entire array that contains 2, 1, 7, and let's say this is 3, 4, 3, 5, and 4. Now let's suppose we have to sort this entire array. So again, this is an entire problem, right? This is an entire problem. And now what I'll be doing, I'll be dividing this into two different parts. So basically, I will partition this array from middle, and I have two different partitions, left partition and right partition. See, if you will look at all the algorithms of divide and conquer, whether it is binary search, merge sort, quick sort, any of the algorithm that comes under divide and conquer paradigm, you will be able to observe that you focus on dividing the problem into sub problem and tackle the sub problem, and then you will be merging the solution of all the sub problems to finally get a working solution for the entire problem. Okay, so over here, this is the same example in which you will be able to observe that divide and conquer means dividing the problem into sub problems. Now this is 217, and the right partition contains 3, 5, and 4. Now again, my target is to focus on this sub problem as B1, sub problem 1, and this is my sub problem 2. Now again, I'll look at this sub problem 1 as an entire problem. So now again, dividing it from middle, let's say this contains 2 and 1, and this will be containing 7. Similarly, again, this will contain 3 and 5, and this partition will contain 4. Okay, and now again, I have many sub problems. Sub problem 1, 1, and this is sub problem 1, 2. This is sub problem 2, 1, and this is sub problem 2, 2. Now again, I will look at this sub problem as an entire problem, and I'll be dividing it into two different partitions. So I will keep on following this process. I'll keep on dividing it until and unless I have a partition for which I'm sure that this is the solution. For a partition that contains a single element, I am sure that the single element is always in sorted manner. So I don't need to worry about arranging anything, right? So this is the finalized sub problem for which I know the answer, right? For a single element, if I tell you to sort a single element, you will be saying that, okay, the single element can be called always sorted, right? Because we can know, because we don't need to compare a single element with any other element. So for a sub problem which contains only a single element, I am sure about the solution, that it is already in sorted manner. So now this is my sub problem for which I know the answer, 217. And now for 3 and 5, again partition will take place. This is my 3, this is my 5, and 7, 4 remains as it is. Now this is my solution for sub problems, right? These are my solutions for the sub problem, not the solution of the entire problem. Okay, so SP11's solution is this two different. So now all these solutions, what I'll be doing now, I'll be trying to merge all the solutions. Now in order to merge, I'll be comparing the solutions of different sub problems. So this 2 and 1 will be compared. Now this merging process will take place. So comparing 2 and 1, whichever is smaller will occur first. So now 1, 2 is now one of my solution for the sub problem. Now again, this 7 remains as it is. So again, doing the same process with 7. Just give me a minute. Let me reopen this. Okay, so this is my sub problem for which I already know the answer. 3, 5, and this is 4. Now start merging this. So 2 and 1 will give you 1 and 2, because I need the arrangement in ascending order or increasing order. So now this is a solution 1 for the sub problem. This is solution 1, 2. Now again merge both this solution. So now merging 1, 2, and 7. So this will give you 1, 2, and 7. I'm giving you a raw idea about how this divide and conquer algorithms work. So now this part 3 and 5, merging it, and 3 and 5, I have a sorted array. So now again merging this solution with the other solution. So 3, 5, and 4. So this will give you a sorted array 3, 4, and 5. Now this two sub problems needs to be merged. and now merging it, and I'll be getting an entire 1 2 3 4 5 and 7. So now at the end, after getting solutions of many small sub problems, I am finally able to find the solution for the entire problem. The original problem was this, it was sorting this array, and now after solving the sub problems, I have arrived at a completely working solution for the entire problem. So basically, this is how divide and conquer strategies work. So any doubt till now? Was it clear? Yes or no in the chat box? Can I get a quick confirmation? Was it clear? Any doubts from your end? If you have any doubts, do write down in the chat box. Okay, thank you, Arushi, for the confirmation. Anyone else? I can see a lot of you have joined the session. I want to make this session very interactive, so it will be very much entertaining for you and me as well, right? And we need enjoyment in this session as well, like, right? Okay, thank you for the confirmation. So now I hope everyone got the basic idea, and everyone who are attending my session for this first time, I'm going to repeat it again and again. If you want to learn any of the topic of DSA, then first of all, what you should do, you should go through all the basic algorithms and all the basic, let's say, basic information, the theoretical part, all the basic theoretical part which comes under that topic. For divide and conquer, you will be able to understand a linear search algorithm. You will get to know about binary search, merge sort, different sorting algorithms. So basically, cover all the theoretical part, for which you need to understand through a video or by reading the article. So now, after completing and gaining the knowledge of all the algorithms, simultaneously you should focus on making notes of this algorithm. Okay, so make some notes and keep on revising those notes. Okay, so algorithm is like, it is a process which you need to know. Okay, it's not that you need to discover the algorithm on your own each and every time. Okay, you don't need to invent the algorithm, and algorithms have already been invented, right? So basically, you need to understand how they are working. You need to know the process. So make down the notes, write down the notes, and keep on revising them. And after completing the theoretical part of a topic, you should move towards solving the standard questions. Okay, so where will you find standard questions? Okay, so in the previous session I explained a lot about standard questions, why they are important. Okay, so let me share you the basic understanding where you will get the standard questions, so that whoever wants to start from beginning, whoever wants to start from beginning, then they can know the path on how to learn each and every topic of DS. Okay, so basically, what I did, I searched for divide and conquer, and then I did gigs for gigs. So this is an entire article in which all the different links over here, you will be able to observe the different introductory topics which are required, right? And then here you will be able to understand that what is the difference between divide and conquer and dynamic programming, advanced master theorem, and what is introduction, what is actually divide and conquer. You can go through this link, and over here you can observe, this is what I was talking about. These are standard algorithms. Basically, this is the theoretical part which you should not miss at all. Okay, so this thing needs to be covered up, and then over here you will be able to observe, these are some of the binary search based problems. These are some of the other practice problems. So basically, this is how you should encounter, and how this is how you should learn about new topics of DSA. Okay, see, standard algorithms that follow divide and conquer algorithm. So this is the list of the algorithms which you should know. Okay, and there might be it is possible that some of the advanced algorithms might have been noted down in the list, but you can ignore those advanced algorithm. But the basic algorithms needs to be covered up, and then focus on solving standard problems. Okay, there will be around 20, or let's say 15, 20 to 25 standard problems in each and every topic, and everything revolves around standard problem. That's the beauty of DSA. Okay, so directly they won't ask you the standard problems in the interview or anywhere else. You need to modify the thought process which you applied for standard algorithms, and that thought process will help you to get solution of any of the uh, question. Okay, by the way, if you don't mind, can I share a Discord group link so we can connect after CodeCamp? You can already connect over Discord channel. Okay, so over there, GFG already has a Discord channel available. You can connect and you can have interaction with some of the geeks like you. Okay, Pratik, over there you will meet lots and lots of people who are aiming for the same thing which you are preparing for, and it will be very much entertaining over there because you'll be getting the updates about the upcoming video session, and so much is happening on the Discord as well. Okay, so now without any delay, let's start the session and let's understand, go with the first question. Okay, so I'll be sharing the link of this question in the chat box, and I want you guys to first of all read down the problem statement, 2 to 3 minutes. Just go through the question, and then I will explain you what the question is trying to say. Okay, so I've shared the link of this question. The first question is, find the element that appears once in a sorted array. So I'll give you 2 to 3 minutes. Just quickly go through the test cases, expected time and space complexity constraint, and just quickly write down +1 if you have gone through the question. Okay, so I'll be waiting for you guys, just getting information from 2 to 3 people, and then we'll be moving forward. Sir, how to write divide and conquer algorithm? See, algorithms are the things that have already been invented. Okay, and if you want to invent a new algorithm, it takes lots and lots of thought process, and you need lots of knowledge for it. So we don't need to invent anything. We need to utilize the thought process which you will be understanding by going through standard algorithms. Okay, I already said that you should go through the standard algorithms, and you will be able to understand how to proceed further with the next question or the practice questions. Okay, so Arushi has already read the problem statement. Anyone else who have completed the reading of problem statement? Okay, Pratik has also done. Anyone else? I can see 9 people have attended this session. Just write down +1 in the chat box if you have understood the problem statement. Okay, so let's understand what the problem is trying to say. So basically, in this question, the difficulty level is easy. So it will be easier. Let's see. So given a sorted array of size n, you will be given an array of size n. And what you need to do, you need to find the element that appears only once in the array. All the other elements appear exactly twice. So from this, I can get an idea that there is a single element which occurs only once, while all the other elements will strictly appear twice, not more than two or not lesser than twice. Okay, except one element in the array. So in this example number 1, you can observe n is equal to 11, and what you need to do, and this is my array elements. Now over here, you can observe each and every element is occurring twice, 1, 2, 3, but I can see 4 is having a single appearance in the array. 50 is occurring twice, 65, and so on. So 4 will be your output. Okay, so this is what the question is trying to say. And if I look at the constraint, then the array can be as large as 10 to the power 5, the size of the array, and the array elements can lie in the range minus 10 to the power 5 to 10 to the power 5. Okay, and the expected time complexity is logarithmic of 5. So now let's understand. So let me give you one more test case, and then this is our question number 1. So n is equal to, let's say, 7, and the array element is equal to, let's say, so now over here inside this array, which element do you think occurs only once? Which element? I can see 10 has a single occurrence, hence the output for this test case is going to be 10, and this is your input. Okay, so now based on this, if you know a specific property about, let's say, first of all, I will ask you guys what can be the solution or what can be the approach of solving this. What do you think? How you can reach down this solution? How can we proceed further? Don't focus on expected time and space complexity. Just focus on, yes, exactly, naive linear search algorithm. The most basic thing which we have already seen by searching for the key in the dictionary. Linear search is an approach. We can apply a linear search algorithm, right? And what will be the time complexity of linear search algorithm? It is going to be order of n, right? Because we need to iterate over each and every array element. And over here you can observe that you will be iterating over all the array elements because the final answer is the last element. And if the final answer is the last element, then you will be encountering all the n elements. So this is how you will be getting the answer by linear search algorithm. So can we do better than this? Okay, so let me give you or give you an idea on how we can proceed further in a different manner. So basically, let's say if you know about a property of XOR, if I do, what will be the output of 2 XOR 2? What will be the output for 2 XOR 2? Okay, Arushi got a different approach and she has mentioned hash map, right? We can use hash map as well. You can map the frequency, right? A mapping of element versus frequency can be done. So what will be the output of 2 XOR 2? Okay, blue says 0. Yes, exactly. So basically, if I do 3 XOR 3, then it will be 0. 4 XOR 4, it will be equal to 0. So basically, if I do A XOR A, it is going to give me 0. XOR of same number is 0. Yes, exactly, Pratik, with itself. So basically, this is the property of XOR. And now I can utilize this property to get the answer. How will I utilize? If I do the XOR of every element of the array, then what will be the final answer? Let's see. So I'll be starting with the element. Okay, inside the element, nothing is present. Now I'll put 3. So next element is 3. 3 XOR 3, it will be 0. So now next element is 4. 0 XOR 4, it will be 4. Next element is 4. 4 XOR 4, it will be 0. Next element is 9. So 0 XOR 9, it is going to be 9. This XOR 9, it is going to be giving you 0. And the 0 XOR 10, it is going to give you 10. And at the end, you can observe your answer is present inside the temporary variable element. So basically, you need to iterate over the entire array. This is somewhat similar to linear search only. The time complexity will be order of n only, but we have utilized the XOR property because we knew that XOR of same element is going to be 0. So this is one of the approach, right? After linear search, you can try out in this manner, do XOR of elements, and the time complexity remains order of n over here as well. Okay, so now what can we do better than this? Can we do better than this? Because order of n is not what is expected by the question. Is math or aptitude required to learn? It depends upon what kind of interview, what kind of questions you will be asked in the interview. Okay, so if the online assessment is going to take aptitude and maths as well, then you need to study it. But if they are not going to ask you any aptitude questions, then you can go with And aptitude is not going to take much time. You can practice aptitude like in 1 to 2 months, and your aptitude for interview is ready. Okay, it is not going to be anything very advanced, not like gate examination or anything. Okay, so now what can we do? Can we do better than this? So now let's observe one thing, and let's take the example which is present over here. I'll be taking this example, and yeah, this is the array, right? So let's take this example. So now over here, the array elements are 1 1, 2 2, 3 3, 4, and 50 50, and 65 and 65. So now if I observe one thing, where is our final answer? Our final answer is present over here. And let me write down the indexes as well. This is 0 1 2 3 4 5. This is 6 7 8 9 and 10. Now on the left hand side, or the left partition of the answer and the right partition of the answer, is something that needs to be observed carefully. The left partition and right partition, there is something very specific regarding the occurrence. In the left partition, is this blue color visible, clearly visible to you guys? Okay, this is kind of easy for me if I was in CSE. No, no, like don't at all, no, don't worry about. Uh, Safwan says like this is kind of easy for me if I was in CSE. No, it does not even matter. If you are from a non-tech background as well, then CSE or the computer science field is very it is open for everyone, right? You can get into CSE and get a very good job if you are from non-tech background as well. Okay, just focus on learning and understand how you can apply your brain. Okay, train your brain, and the life in computer science is very easy for you. Both are even length. No, not about length. Regarding the occurrence of element, left partition. So inside the left partition, if you observe that the first occurrence of the element and the second occurrence of the element, the first occurrence will always be at the even index, and the second occurrence of that same element will be at the odd index. Okay. And in the question, it is also given that, yeah, you can observe that the array which will be given to you in the question is sorted array. You can observe this line. Given a sorted array, the array is always going to be sorted. Okay. So basically, the first occurrence in the left partition of an element is going to be even, and the second occurrence is odd. Similarly, now let's observe the same thing for the right partition. What do you think? What will be the case for the right partition? So now for the right partition, you can observe the opposite of it. Are you guys able to see? Are you guys able to observe in the right partition? You can observe that the first occurrence of any element, you can observe this 50. Let me target this 50. 50's first occurrence is at 7. You can observe 65 also. 65's first occurrence is at 9. Basically, they will be having their first occurrence at odd index, and the second occurrence will be at the even index. Okay. So we can observe that this is the observation I am able to apply over here. So now what you need to do? Now in order to find our key element, basically I will be discarding either right partition or left partition each and every time. I will not apply a linear search, I will not apply iteration over the entire array. I want to apply divide and conquer, and inside divide and conquer I know that I have to work on the sub problem, or sometime if it is possible I can discard the other partition. So basically now in order to apply this divide and conquer strategy, I'll be using binary search algorithm, because if you have understood the problem properly, you can observe that this problem is of searching. You need to search for that element that occurs only once. So now I'll be applying the binary search algorithm. So I've started the binary search from 0th index. This is my low and this is my high, right? So my low and high will be at this position. I will explain at the end what is the reason behind not keeping the high at the last partition. Okay. So now we know the binary search algorithm. Binary search algorithm. Just give me a minute. Okay, will year gap affect to get product-based companies with a non-CSE background? See, a gap of a year without any experience might affect, like if you have not worked for an entire year and you are trying to get, so there might be some kind of like the company will be having some kind of policies for this. Okay, so don't you worry. It is not at all. It is not going to affect any kind of thing, but it depends upon company because policies change from company to companies, right? You can keep on trying. It does not matter for every company. For some companies which I have not heard about, it might matter. They will ask you the question, what were you doing for that 1 year? Basically you should have a clear cut idea or clear cut explanation that what were you doing for 1 year. Okay, and it should be a genuine reply from you. Okay, so let's start. So I have started applying the binary search algorithm. So now over here I will be uh, finding the key element. So what will be the binary search algorithm? Inside binary search, we apply the mid element. We need to find the mid element. So 0, that is low plus high divided by 2, and 0 plus 9 divided by 2 will be giving you 4 as the mid element. So this is going to be my mid element. So now, was it clear? You can use count method in Python. Yes, we can use count method, but we need to understand how we can apply divide and conquer. Okay, there might be inbuilt methods present, but we need to know about without using inbuilt method. Okay, so now after applying the binary search algorithm, I encountered this element 3. So now what is the index of this 3? I know that the index of this 3 is 4, and we know that whether it is left partition or right partition. So I'll be checking whether this is my left partition or right partition. If this is not my left partition, then obviously it is going to be my right partition, and vice versa is true, right? So for left partition, I'll be checking whether my mid is present inside my left partition or not. So basically, I encountered mid, and mid says 3. The element is 3. And what is its index? I can observe the index is equal to 4. That is odd index. I mean, even index, right? This is my even index. And we know that for the even index, it denotes the first occurrence. So is this my first occurrence? Yes, this is going to be my first occurrence. So basically, I have encountered that this is my first occurrence. So if this is your first occurrence, then that means this much of part is your left partition. This part is the part of your left partition, and my element is not going to be in the left partition, right? Because in the left partition, first will be at even and the second will be at odd, and the affection for the it will affect on the right partition. If I have a single element, then the ordering will be changed for the right partition only. Okay, so I'll be discarding this left partition, and how to discard the left and right partition, we will be just shifting your low to mid plus 1. So this will be my low 9 right now. So now this is the partition in which you will be looking for your key element. So now currently your low is pointing to 3, I mean to 5. Now apply what will be the mid of this partition, that is 5 plus 9 divided by 2. So this will be giving you 14. 14 divided by 2 will be giving you 7. This is my mid. And now let's check. So this is my mid. And what is the index of this mid? This mid is present at the index number 7. And 7 is an odd element. Seven is an odd element, right? And for odd element, we know that if this is going to be my left partition, then the second element is going to be at the odd index. But over here you can observe this is 50. And is this the first occurrence or the second occurrence? This is the first occurrence of 50, right? How to know with whether this is the first occurrence or second occurrence? So what I'll be doing, I'll be checking the element present at the mid minus 1th index. If the element at mid minus 1th index and the element at mid, both of them both of them are equal, then that means this is your left partition again. But this is not the case, right? But this is not the case. Mid minus 1 and mid are not same, so this is your right partition. And now what you can do, if this is your right partition, this much of part will be in your right partition. So I'll be discarding the right partition. How to discard the right partition? You will be bringing your high to mid minus 1. So your now high will be pointing to this is your high, and this is your. So are you guys getting my point, what I'm trying to do? If this is my left partition, then I will discard it. If this is not my if this is not my left partition, then that is going to be your right partition. So now again applying the same process over here, finding the mid, that is 5 plus 6 divided by 2 will be giving you 11 plus 2 will be giving you 5. So this is going to be your mid element. So this is my mid. So this is my mid, right? I'm extremely sorry. Okay, so let's get it back again. So this is going to be a mid. So applying, finding the mid for this partition, and for this partition, what will be your mid? So 5 plus 6 divided by 2 will be giving you 11, and 11 divided by 2 will give you 5. And this is my mid. And now again checking, if this is the mid and what is its index, it is 5. Is it odd? Yes. So this defines that this is my second index. So if it is your second index, you need to check what is the element at mid minus 1. If it is similar to what the element is present at this mid index, then you will be discarding your left partition. I can observe mid minus 1 and mid both have the same element. As both are having the same element, I will discard the left partition. So basically, I'm trying to shrink the left and right partition such that I will be having at the end my low will be pointing to the key element. Okay, so now I'll be discarding. So what I'll be doing, this is my mid, and this is where the low is standing. So I'll be discarding the right partition. So I'll be doing mid, low is equal to mid plus 1. So I'll be shrinking the left portion. So now your low and high are pointing to the same element. And you can observe we are getting closer to our key element, right? Yes or no in the chat box till now? Was it clear? Yes or no? Any doubt till now? Yes or no? A quick reply from everyone in the chat box. Any doubt, anything from your end? Okay, I guess it was clear to everyone. So let's start. So now again applying the same process, finding the mid. So mid will be what? 6 plus 6 divided by 2 will give you 6 again. And now this is my mid. So now I'll be checking what is mid value. It is 6. It is even or odd? It is even. So that says if this is going to be my left partition, if this mid is in my left partition, then that means at even I'll be getting the first occurrence. So if this is my first occurrence, then this is going to be my second occurrence, right? Okay, thank you for the confirmation. You can use okay, Swadeep and Pratik. So 6 says that this is even, and for this left partition, I know that the first occurrence will be at even index. So is this my first occurrence? No, I can observe that at mid plus 1th element, 7 is present, right? So the second element should be present at the mid plus 1th position. Okay, I'll write the pseudocode as well, but this understanding is also important. Okay. So I can observe this is not the case. So at the end, you will be able to observe that this partition is where mid is pointing is our key element. Okay. So basically, let me give you an idea about the algorithm, how this algorithm works. So basically, we are going to apply binary search algorithm where our low will be starting at the 0th index and our high will be present at the index last minus 1. Our high will be pointing to this index. And the reason for this is that let's say if your key element is present at the last index, let's say this is how your array looks like. So now if your key element is present at the last index, then if you have applied binary search on this much of part, then only then your left portion will be shrinked and your low will be at this point, and high, that will be the right portion, will be shrinked. If you will not start in this manner, that is from the index n minus 2, then it will not be able to handle the case in which your answer will be the last element. You can try this. You can try keep your high at n minus 1th position and try to apply. You will be able to understand and get a better picture. Okay, so your high will be equal to n minus 2. Was it clear? What was it clear about low and high? Low and high? Okay. So now this is where my high and low is, right? And I will be applying the binary search algorithm. So binary search algorithm starts with the low lesser than or equal to high. And now I need to find the mid. Mid is equal to low plus a high divided by 2, right? And now I will not check whether my mid is even or odd. What I'll be doing, I have an interesting technique to check whether my mid is even or odd. So if let's say array of mid and array of, let's say, array of mid XOR 1. So basically this and this, basically let's say if I have 3, the binary representation of 3. Now if I do XOR of 3 with 1, what I'll be getting? I'll be getting 1 XOR, I mean 1 0, that is equivalent to 2. So basically let's take one more example. Let's put the value of mid. Let's say if mid was equivalent to 3. So mid XOR 1 will give you what? It will give you 2. And let's say mid was an even number, 4. So let's say what is binary representation of 4? That is 1 0 0. And I'm doing XOR with 1. And this will give you 1. So this will give you 5. So this is how you will be able to switch. So basically for mid, which is going to be even, what you will be doing? For left partition, we know that if the mid value is equal to even, if the mid value is equal to even, then what? I need to check whether this element is the first occurrence or not. So basically I need to check at mid plus 1. But before that I need to check no whether mid is even or odd. And let's say if mid is equal to odd, then that means the current element might be the second occurrence, right? If mid is odd, then the current element might be the second occurrence in the left partition. So what I need to do, I need to check whether this is second occurrence or not by doing mid minus 1. So basically I need to check mid is even or odd. And in order to not do this thing, I am just simply checking the element present at mid and mid XOR 1. Okay. Was it clear? Now, is it making sense? What is the reason behind not checking mid is even or odd? Basically, this thing will handle both the cases. Okay, a quick reply from everyone in the chat box so I can understand that you guys are able to get this point. High explanation. High this variable. High explain. What does it mean by high explain? Okay, so for high, why I took my value of high as n minus 2. Take an example in which the last element is the non-repeating element. Okay, if the last element is non-repeating element, and let's put high over here and let's put low over here. If we'll apply the binary search full process, then you will be able to understand you are missing the key element. Okay, you will this high will try to shrink the right partition and low will try to shrink the left partition. Okay. Okay, so now this is how I'm handling this part of even and odd for mid. If this is equal, then basically either you are in right partition or in left partition. You need to ignore. If this is true, then that means your current partition is your left partition, right? As we saw over here, this is your left condition for your left partition. So basically I will discard my left partition, so I'll be moving my low to mid plus 1. Okay, and if this is not my left partition, this condition does not hold true, then what? Then that means obviously my mid is standing in my right partition, so I'll be moving or discarding my right partition. So basically I'll be doing high is equal to mid minus 1. Okay, and here is our ending of the while loop. And at the end, after this condition is completed, your answer will be present at the index low. And at the end, this is the end of our entire function. Our final answer will be present at the low. Basically, low and high will try to, this is your key element. So basically, this low will be standing over here and high will be over here. They will completely try to shrink this partition. They will completely try to shrink this partition, and at the end, they will cross their path, but low will be pointing to your key element. And whenever they cross their path, you will stop your binary search, and at the end, low is pointing to this. So they will help you to shrink or discard the left and right partition. Okay, so this is how binary search works on it. Okay, so now let's directly jump to the coding implementation for the same, and let's directly get the solution part. Is it clear? Any doubt till now? Yes or no? If it is clear or if any doubt. Or else let's start coding. If low is equal to what? Let's say low is equal to 0, and I know that high is going to be my n minus 2 index, second last index, right? And I have the condition as while low is lesser than or equal to high. I'm applying the binary search algorithm. First of all, let's try to find the value of mid. and after that I need to check whether currently I'm standing in my left partition or not. If array of mid is equal to array of mid XOR 1, if this is my currently I'm in my left partition, then I'll shrink the left partition by doing low is equal to mid plus 1. If this is not my left partition, then this is absolutely my right partition. So I'll shrink my right partition by doing high is equal to mid minus 1. Okay, so this is the entire binary search, and now at the end, whatever is the key element will be present at the index or the position pointed by low. Okay, can you do with Python? Okay, so with Python, see, this thing can be done in any of the language. This algorithm, the reason for writing the algorithm is that you can code it on your own in any of the language. Okay, so I'm choosing Java for now, but the solution will be available as well. So now let's try to see and check the acceptance. Any doubt till now? Anyone? So let's try to compile and run. Okay, so the compilation was completed. Let's try to submit and see what does it give. And we can see that the problem is successfully submitted. So this is how we can think about. See, whenever you look at a question and it says divide and conquer, let's suppose it says divide and conquer. Okay, so let me give you a trick to understand where can you use binary search, because you will encounter many questions in which you might have not even imagined that binary search algorithm can be utilized. Okay, there are going to be many complex questions in which you can't imagine binary search algorithm at the first go. So basically, whenever you encounter that this question is under divide and conquer strategy. Okay, so basically, if you look at the topic text, there will be divide and conquer. If you see divide and conquer and the question says you have to sort or look for an element, this kind of an element, then you can apply binary search algorithm. And there are many questions which I have encountered, and those questions were like, you might have not imagined that how to directly apply on the answer. You will also encounter such questions in which you will be looking for the answer in a range of answer. Okay, so basically you will be able to know, you are aware that your answer will be in this range. Let's say it will be in the range 0 to 10 to the power 9. You are sure that your answer is always going to be in this range 0 to 10 to the power 9. So there are many questions in which you will be applying binary search on this range of answer and checking whether this, let's say you encounter 10 to the power 5, can be your answer or not. Okay, so basically if you see divide and conquer and if it says searching, you need to look for a word, then basically you can think of binary search, and all those questions will be very interesting to solve, and you will be like amazed how the binary search can help you. So sir, if array is not sorted, then how to solve the problem? So yeah, for binary search you need the array to be sorted, right? The unsorted array will not work. Okay, so now let's move to the next question. Let's start the second question. Let me share the link of the. So I've shared the next question, and the name of the next question is kth element of two sorted arrays. Okay, start reading the problem statement, and we'll be getting back to the question understanding. Over here, the problem statement is pretty much clear. 2 to 3 minutes are more than enough. Just go through the question part. Okay, Pratik says XOR will be optimal, I think. Okay, so I've shared the link. Start reading the problem statement, and as soon as you have completed the reading part, just mention +1 in the chat box, and I will get back you to guys. Have you guys read the problem statement? Okay, Arushi says yes. And what about the other guys? Pratik, Shivam, have you guys read the problem statement? Okay, so let's uh, start with the question and let's understand. Kth element of two sorted arrays. So over here, the question says that you will be given two sorted arrays, array 1 and array 2, and it is going to be of size n and m. What you have to do, you have to find the kth element. Okay, so if you merge both the sorted arrays, what is going to be your kth element? That is what you have to find out, and the task is to find the element that would appear at the kth position of the final sorted array, right? And in the constant, if we take a look, the size of the array can be as large as 10 to the power 6, and the array element can be as, it will be smaller than int max, and it will be as small as 0, and key can be as large as n plus m. Expected time complexity log n plus log m. So let's understand with this example. Okay, so question number 2, and what was the array? So array contains array 1, it contains 2, 3, 6, 7, and 9. And array 2 contains 1, 4, 8, and 10. And what is the value of k? K value is equivalent to 5. So now you have to find the kth element. If you sort the array, what will be the element present? So let's sort it. I mean merging both the arrays. So that would be 1, 2, 3, 4, 6, 7, 8, 9, and 10. Right? So this is This is the sorted and the merged array. And now what is the fifth element? This is first element, second, third, fourth, and fifth. Fifth element is 6, hence the output for this comes out to be 6. That is what the question is asking you. Okay, and let's say if k value was not equal to 5, it was equivalent to 7. So after sorting, which is the seventh element? This is first, second, third, fourth, fifth, sixth, and seventh. This is your seventh element, so 8 might have been the output. Okay, so the question is very simple, but the logic is little bit trickier to understand, so pay attention while I'm explaining the logical part. Okay, and this is a variation of standard question. This is a variation of standard question, and let me tell you the name of that standard question. That is, find the median of two sorted arrays. Okay, if you have to find the median of two sorted arrays, if you know that standard question, you will be easily able to understand this question, this solution part. So now, what do you think? How can we find the kth element? Anyone from the audience? What do you think? How can we find the kth element from this two sorted array? How? What do you think? First, applying merge sort. Okay, so try to think, Anushri. Try to think. Do you really need to apply merge sort algorithm? You are absolutely correct. Applying merge sort and getting the final array will completely work, but I don't think merge sort is required. These arrays are already sorted, and inside merge sort, there is a process called as merging of two arrays, right? We can apply that process and merge it directly without utilizing n log n time complexity, and that can be done. Merging can be done in order of n plus m. Okay, so that will be better than it, better than applying merge sort. Pratik says order of k, merge till we reach the kth index. Yes, exactly. That is what I was trying to say. So basically, merge is a procedure of merge sort algorithm. And let's say if you have to merge these two sorted arrays, how do you merge? You keep two pointers, let's say pointer 1 and pointer 2, and you have an empty array. So now what I'll be doing, I'll be checking whether P1 is smaller or P2 is smaller. I can see P2 is smaller. So place that element over here. Now move P2 forward. Now which is smaller, P1 or P2? I can see 2 is smaller. So P1 will move forward and 2 will be placed over here. Now check. Along with this, you can keep a counter. You can keep a counter because you need to find the kth element only, no? So what I'll be doing simultaneously, I'll be having a counter variable that how many elements have I encountered. Okay, till now I have encountered two elements. So now again comparing which is smaller, P1 or P2. 3 and 4, which is smaller? 3 is smaller, so move P1 forward and put this 3 inside your array and increase the counter by 1. Now, which is smaller, 4 or 6? I can see 4 is smaller. So P2 is moving forward and counter says 4, and this 4 element will be present. Now which is smaller, P1 or P2? 6 is smaller. So 6 will be placed and your counter says 5 and P1 moves forward. And as soon as your counter is equivalent to K. Okay, Anushri, okay, got it. Okay, so if your counter says K, then stop the merging procedure. And which was the last encountered element? 6 was the last encountered element, and that is going to be your output. Over here, there is no requirement of creating an array. You can keep a small variable that says element, and whenever you encounter a smaller element, update your element. And whenever your counter is equivalent to 5, whatever is the value of this element variable, just print it in the output. So that is going to be my approach of finding the kth element of two merge sorted arrays. Was it clear or not? Yes or no in the chat box. +1 in the chat box. A quick reply from everyone if it was clear to you. Okay, thank you for the confirmation. And what will be the time and space complexity of this approach? The time complexity of this approach will be equivalent to k. That is, your counter will encounter k a number of elements. Okay, so basically you will be iterating over k number of elements. And what about the space complexity? As I mentioned, nothing extra, only two variables will work, and this is going to be my time and space complexity of this approach. Order of k and order of 1. Okay. Any doubt in the time and space complexity? So now, can I do better than this? I don't want to apply this kind of logic, a simple logic. I don't want to apply linear solution. I want a better approach than this. Okay. The interviewer might say, why don't you utilize the property of the arrays? Because arrays are already sorted. See, if you are given that arrays are already sorted, then you somehow need to think how to utilize that, how to take it as a benefit, and how to get the time complexity reduced compared to what you can have in a brute force approach. I'm using the same input test case, and now let's see. Okay, the kth element. Let's observe carefully the kth element. So now what I'll be doing, I need to find this kth element, and this is going to be my sorted array: 1, 2, 3, 4, 6, 7, 8, 6, 7, 8, 9, and 10. Okay, and where is your kth element? Your kth element is over here. This is your kth element. And over here again, observe in this manner. This is your left partition. This is your left partition, and this is your right partition. Okay, so in the left partition, there are some elements from the array 1, and there are some of the elements from array 2. I'm giving you the intuition on how you can think of binary search. Okay, so pay proper attention over here. If you understand the intuition part, you yourself will be able to understand, or you yourself will be able to build a completely new binary search based algorithm. So pay proper attention, everyone. Okay, so this is my key element, this is my left partition, and this is my right partition. So in the left partition, there might be some of the elements from the first array, and there might be some of the elements from the second array. Similarly, in the right partition, array 1 and array 2. So now, how many elements are there in your left partition? How many elements are there in your left partition? There are only 4 elements, right? So what if somehow I am able to find the number of elements in my left partition along with the answer? Somehow, if I am able to find out the elements in my left partition along with the answer, that is, somehow if I'm able to find out k number of elements, k smallest elements from array 1 and array 2, and don't you think the largest element in the set of k smallest element is going to be my answer? Let me repeat. Somehow, if I'm able to find k smallest element from this array 1 and array 2, then don't you think the largest of k element, all the k elements largest, is going to be your output? Don't you think so? Yes or no in the chat box? Yes or no? Yes, that's we did in the previous approach too. Yes. So basically, I took such questions from which you will be able to understand the mindset of this paradigm. Okay, got it? Okay, so now let's try to understand. Somehow I'll try to find the kth, k smallest element and take the largest one of it. So what I'll be trying to do, I'll be having two different partitions. Partition 1, that is left partition, and the right partition. Left and the right partition. So now what I'll be doing, I'm not sure how many elements will be in the left partition. There will be k number of elements along with the answer in the left partition. So what if I take some of the elements from the left partition from array 1? Is it visible to everyone? I guess so. From array 1 I'll be able to take, let's say, 2 and 3, and from array 2 I'll be able to take 1 and 4. So is it clear or not? This part, left partition. In the left partition, I included few of the elements. I included, basically in the left partition, you need to have k number of elements. So I included 2 and 3 from array 1, and now I'll be including 1, 4, and 8 from the array 2. So what will be in the right partition? Array 1 will contain 6, 7, and 9, and array 2 will contain what? It will contain 10. Contain a single element. So do you think this is a correct partition? Do you think this is the correct partition? I need to understand whether this array 1 will contain the correct elements or not. How to identify whether this partition is correct or not? So basically, observe carefully this part. So basically, let's check whether the elements of array 1 is correct or not. The elements present in the array 1 are selected in a correct manner or not. Can I include them in partition 1 or not? So this is array 1. So 2 and 3. So I need to check whether this 2 and 3 is going to be there in the left partition or not. How to check? Let's go back over here. You can observe this 2 and 3. All the elements on the right hand side of 2 and 3 are going to be greater than 2 and 3. You can observe all these elements are greater than 2 and 3, right? So basically, the array 1 and array 2 are already in sorted manner. So now over here, if I compare the elements or the content of the first array in both the partitions, let me erase this part, 148. So 2 and 3, this justifies that 6, 7, 9 is always going to be greater than 2 and 3, because it is the part of the same array, and the array given to us is already in sorted manner. So what about the comparison with the element of the array number 2? What about this comparison? So I need to check whether this 3 is lesser than 10 or not. So for that, this first element of right partition of array 1 and first element of right partition of array 2, I'll be calling it as R2 and R1. I repeat, R1 is the first element of array 1 in the right partition, and R2 is the first element of array 2 in the right partition. And L1 and L2, what is L1 and L2? L1 is the last element of array 1 in the left partition. This is array 1, this is array 2. Now you can observe array 1 and array 2. Is it making sense? L1, L2, what is L1, L2, and R1, R2? Yes or no in the chat box, a quick reply from everyone whether this part is clear to you or not. Okay, thank you, Pratik, for the confirmation. So now what I'll be doing, I will be somehow finding that where how much element from array 1 should I include in the left partition, and how much of the elements should I include from array 2 in the left partition. I need to put this partition in a correct manner. Okay, I need to find the cut of this partition from array 1 and array 2. So I checked for array 1 whether the elements of array 1 are correct or not. Now I need to check whether the elements which I have selected for array 2 is correct or not. So I'll need to compare. I need all the elements in the right partition to be greater than the elements of left partition. Okay. So now I know that array 2 elements are 1, 4 and 8. And this is the element from the same array. So I know that obviously 10 is going to be greater than the all the elements in left partition, right? So what about this inequality? What about this comparison? I need to check with the elements of array 1, because for array 2 elements, obviously they are in sorted manner. So comparison is going to be in sorted manner only, right? So I need to compare 8 and 6. And as I mentioned, this element are present in the right partition, these elements are present in the left partition. And in the sorted array, right partition contains all the elements that are greater than left partition. And so basically 8 should be lesser than 6 actually, but this is not the case. This is not the case. So the elements which I have selected from array 2 for left partition is not true. So I need to discard this 8, and 8 should be rather present over here. If I'm putting 8 over here, the number of elements in the left partition should be always equal to k, because my answer will be in the left partition only. But this is not the case over here, right? So I need to include one of the element from the right partition. So I'll take this 6 and put it over here. I repeat, I need k number of elements in the left partition, not more than k, not lesser than k, strictly k. So I moved this 8 because it should not be in the left partition. So I placed this 8 in the right partition. So now I need to get one of the element of right partition and put it over here. So I placed this 6 over here. Okay. Now this 6. Now one element was removed and one element was included. So basically the element 8 should be actually lesser than 6. So I need to decrease 8 and I need to increase 6. Okay. Basically this is what I was trying to do. So now again let's check whether this element which I have placed in the left and right partition is correct or not. So let me just make it more clear. This is 2, 3 and 6. And this is my L1, this is my L2 now, and this is my R2. Okay. So now again doing the comparison and checking whether elements included in the left partition are correct elements or not. So let's check the choice for array 1. Till now, was it clear or not? Can I get a quick yes or no from everyone? A quick reply, a quick plus or yes or no in the chat box if it was clear to everyone. Okay, thank you for the confirmation, both of you. So now let's check for array 1. For array 1, let's check whether the elements selected are correct or not. So I'll be comparing with L1. L1 comparison with R1 will always be true. That L1 is always lesser than or equal to R1 will hold true always, because the array, you still confused how we partitioned first time. I randomly took the partition and I'm showing you. Okay, so the partition part is not yet discussed till now. I'm showing you that if my partition is correct or not, how to identify whether the partition is correct or not. Okay, I just randomly took the partition and I am showing you how to check whether the partition is correct or not. Okay. Okay. So now L1 is lesser than or equal to R1 will always hold true. So I need to check L1 is lesser than or equal to R2 or not. Okay, because they are elements of different array. L1 is lesser than or equal to R2, yes or no. That is 6 is lesser than or equal to 8 or not. Yes, it is true. So this choice 2, 3, 6 from array 1 is completely correct. Now let's check the choice of elements of array 2. So this one and this one. So L2 is lesser than or equal to R2 holds true always. It is going to be true always because they are elements from the same array, right? Now, what about this part? I will be checking whether L2 is lesser than or equal to R1 or not because they are the elements from the different array. This two comparison needs to be done. So L2, that is 4, is lesser than or equal to 7. Yes or no? Yes, this is also true. So this both conditions are very important, and if these two conditions are satisfied, then it means your choice for the left and right partition is correct. Whenever you encounter this condition, then that means the element which the k elements present in the left partition and take the largest element, that is largest element will be nothing but a maximum of L1 and L2, right? Because they already are in sorted manner, so maximum of L1 and L2, that is maximum of 6 and 4 is giving you 6, and then 6 is the output for this one. Got it? Everyone, yes or no? Okay, Pratik, was I able to clear your confusion? Okay, so now here comes how will you select the partition, right? Here comes our main story. How to select the partition. So basically, I need to apply binary search somehow. Okay, I'm not sure on which array. So let me give you an idea how to apply binary search. So over here we have two different arrays. Okay, so now I'll go quickly and let's not stretch it a lot, right? So now I'll be applying binary search algorithm. I have two different arrays, right? And I want my target is to apply binary search in such a way that I don't need to somehow increase my time complexity should be decreased by applying binary search. So basically, I can apply binary search on either of this array. But in order to make the binary search algorithm efficient for this question, I will apply the binary search on the smallest length array. The array which is having the who is the shortest array, I'll apply binary search on that array. Over here from array 1 and array 2, I can see array 2 is the shorter one. So I'll apply binary search on 1, 4, 8, and 10. And over here, this is 2, 3, 6, 7, and 9. Okay, so I'll apply binary search on this partition. So now, if I'm applying binary search, I'll be able to know about partition of a single array only. No, as I mentioned, I'll be applying it on a single array. So how will I know that what is the partition for the next array? What is the partition for the second array? So basically, let's say I applied a partition over here. I said I'll be including this many elements in my left partition. So what is this count? This count is 2. And how many elements I need in the left partition? I need k number of elements. And what is k over here? According to our example, k was equivalent to 5. So basically, how many elements from array 1 should I include in my partition number left in my left partition? So k minus 2, that will be 5 minus 2 is equal to 3. That means only 3 elements should be included. So basically, I'll apply partition that is cut 2 in this manner, cut 1 and cut 2. Is it making sense? Let me explain you once again. So basically, just let me reopen this. Once again, pay attention. Once again, I'm explaining this part. So I'll be applying binary search on one of the shortest array. Okay, so I selected array number 2. And now somehow I chose this as my partition and I'm calling it as cut number 1. So this says that the left partition, this many arrays will be included in my left partition. How many elements are there? 2 number of elements. Okay. And in the left partition, how many elements should I include? I have to include only k number of elements in my left partition. So in my left partition from array 1, I'm saying I placed a cut over here. So 1 and 4 will be in my left partition. Now for array number 2. Now in this array, where should I put the cut number 2? So that all the elements in the left hand side of cut number 2 will be in your left partition. So basically, in this left partition, only 5 elements are allowed, only 2 elements are present, already present. 5 minus 2 will give you 3. So I can only select first 3 elements, and this is going to be my cut number 2. Now, is it making sense now? Are you guys able to understand how applying binary search on one array will help you to get the number of elements in the left partition of the other array as well? Yes or no in the chat box if it is making sense. Yes or no in the chat box. Okay. So now this is how I'll be applying binary search. Now let's say, but what if 2, that is first array divide, was greater than k? What if 2? Okay, so what if it was greater than k? So I will apply binary search in such a manner that only k or lesser than k number of elements will be part. See, you asked a very good question. So Pratik, what I'll be doing, let's say I'll not take the value of k as 5, okay, because 5 or k is greater than the number of elements in my first array, that is this array on which I'm applying binary. So let's say k was equivalent to 3, right, and the size of this array is equivalent to 4. I'm clearly able to observe. So basically, you are trying to say, let's not take k is equal to 3, let's take k is equal to 2. K is equal to 2, smaller than it. So now let's say somehow I chose this partition, I chose this cut as this one. Somehow I applied a cut 1 at this because I was not sure about what will be the range of this low and high in my binary search. So basically, I will every time I will choose the low and high, what I'll be doing, I'll choose the low and high in such a manner that it will lie in this range of k only. Either it will be equivalent to 0 or it will be equivalent to k, but not greater than that, because it is not required. No, over here also, if I'm applying binary search on this for k is equal to 2, I'll keep my low over here and I'll keep my high over here only. Okay, I'll not start the binary search from here. So low and high will be chosen. Low and high will be chosen in such a way that only k number of elements will be included from either R1, array 1 or array 2. Is it clear? Pratik, was your confusion clear? Yes or no? Okay. So now I'll keep on applying the binary search and then I will check L1 R1 and L2 R2. So let's start and apply binary search quickly. Let's go through the dry run and let's get this done. Okay, so k is equal to 5. So now I'm applying the binary search. So low, let's say for k is equal to 5, I know that from the first array, from this array, I can include all the elements in the left partition or I can include none of the elements, right? So let's say I'm including all the elements. That means 0 elements can be included or 4 number of elements can be included, right? So I'm applying the binary search on this array. See, low and high are not applied on indexes. They are applied on how many elements can you include from this array. I can include 0 or 4 elements. Okay, low and high does not indicate indexes only. They simply don't every time indicate indexes. Basically, this is indicating partitions. Cut over here, cut over here, cut over here, cut over here, or cut over here. Okay, so this low and high indicates the cut number of cut, which number of cut you are applying. So basically they include how many elements you are including, 0 or 4. So let's say, now let's apply binary search algorithm. So 0 plus 4 divided by 2 will give you 4, divided by 2 will give you 2. So that means I'm including only 2 elements, so my cut will be over here. This is my mid position. Okay, so now this is my C1. So what will be C2? C2 will be present at what? It will be present at k minus C1, and this is actually my C1, that is cut number 1. So k is equal to 5, 5 minus 2 will be equivalent to 3. So I can include 3 elements in my from my first arrays. This is my cut 2. If the size of both the arrays are same, then we can choose any of them, right? Yes, obviously. If the size is same, then you can go for any of the array. So this is my cut 1 and cut 2. And now let's identify L1, R1, L2, R2. This is my L1, this is my L2, this is my R2, this is my R1. Now, what do we need to check? Whether this cut is at a proper position, and I need to check whether L1 is lesser than or equal to R2, and I need to check whether L2 is lesser than or equal to R2. If this condition holds true, then that means my cut is at the correct position. And if this condition holds true, then what you need to do? Then your answer is nothing but maximum of L1 and L2. Why maximum of L1 and L2? If this is your correct cut, then that means this many elements will be in the left hand side, and the maximum of this element is going to be your required kth element, and maximum of all this element will be maximum of L1 and L2, right? Okay, so let's check whether this condition is true or not. L1 is lesser than or equal to R2. 4 is lesser than or equal to 7. Yes. And what about L2? 6 is lesser than or equal to R1. Yes, exactly. This condition holds true. And luckily, while applying the binary search for the first time, we were able to apply the cut at the correct position. And our answer will be what? Our answer will be maximum of L1 and L2. What is L1? L1 is 4 and L2 is 6. 4 and 6 comes out to be 6. If this is not true, then what I'll be doing? I'll be shrinking the left and right partition. Let's change the value of k. Till now, was it clear? This part was clear or not for k is equal to 5? A quick +1 in the chat box. Now let me erase this and apply binary search with a different value of k. So you will get a better understanding, okay? So now let's change the value of k, and I'll be taking the value of k as, let's say, 6. Now k is equal to 6 and the same array, okay? Nothing is being changed. Now k is equal to 6. Now low and high. See, over here there are 4 number of elements. That means in the left partition, all the 4 elements of this array can be placed, or I can place only 2 elements from the second array. So your high will be 4. That means 4 elements can be included. Else you can include 0 elements as well, because in the second array there are sufficient number of elements. No, in the second array there are only 5 number of elements. So low can be not equal to 0. At least you need to include one of the element from array 2. It is compulsory, because if you are saying that low is equal to 0, then that means from the first array I am not choosing any of the element. But if you don't choose any of the element, then let's say in the left partition all these elements are included, then and also then it does not have the sixth smallest element. So at least you need to take one of the element from the array number 2. So now over here I will not give the value of low equivalent to 0, but I'll keep the value of low as 1. Now let's apply the binary search on this range. So cut 1 is equal to 1 plus 4 divided by 2, that is 5 divided by 2 is equivalent to 2. So that means I can include 2 elements. So my cut 1 is over here. So what about cut number 2? Where should I put my cut number 2? It is equivalent to k minus cut number 1. K is equal to 6, and 6 minus 2 will be equivalent to 4. Then that means 4 elements can be included. So here is my cut number 2. So now are you guys able to understand the process, what is happening? Okay, orally, before there I was orally explaining you. It might have confused you, but now are you getting the idea what we are trying to do? Everything revolves around cut 1 and cut 2. Only this. Okay, so now this is my cut 1, cut 2. Let's identify L1, R1. This is L1, L2, and this is R1. I mean R2 and R1. This is R1, this is R2, this is L1, and this is L2. Okay, so now let's check if this condition is satisfied. L1 is lesser than or equal to R2, that is 4 is lesser than or equal to 9. Yes. And what about L2? So L2 is not 6, L2 is equivalent to 7. So basically, 7 is lesser than or equal to 8. Yes, exactly. Over here, luckily, we got this condition to be true. So basically, this condition holds true. So your answer will be maximum of L1 and L2. So what is L1 and L2? L1 is 4 and 7. Maximum of 4 and 7 will be equivalent to 7. So let's check whether 7 is the correct answer. That is 6 largest element. 1, 2, 3, 4, 5 and 6th. Yeah, 6th largest is 7. So this is how our algorithm works. Is it clear? Yes or no in the chat box? And high with respect to different arrays. What will be the logic for it? Okay, so the logic, the part in which how to choose the value of low and high. Okay, this is array 1 and its size equivalent to n. This is array 2 and its size is equivalent to m. Now let's say the k value is given to you. Now I need to partition both these arrays into two different parts. The left partition will contain only k number of elements. Now I am applying the binary search algorithm on the array number 1 that contains n number of elements. So low indicates how many elements can I include from the array 1, and high indicates how many maximum elements can I include. So let's say if I am saying that low is equal to 0 and high is equal to n. So what does it mean? It means that I'm including either I can include 0 elements or I can include all the entire array in the left partition. Okay, so let's say if I'm saying that low is equal to 0 and I have a condition that the value of m is lesser than k. If m value is lesser than k, then I cannot place all the elements of second array inside my left partition, because it will not help me to get the kth element. I at least need to include some of the elements of the array number 1. Okay, and whatever is the difference of this m and k, that many elements should be included from array number 1. That many number of elements should be included from the array number 1. Then and only then your left partition will contain k number of elements. And let's say m minus k was something, that many number of elements needs to be included. So your L will be equivalent to 0, or it will be equivalent to k minus m. Whatever is minimum, it will be equivalent to it. Okay, either you can include 0 or you can include k minus m number of elements. Then only then left partition will contain k number of elements, and your high will be equivalent to, this is going to be maximum. Okay, so maximum of 0 and uh, k minus m, and high is equal to minimum of high can be all the elements or k elements only. Right, it is possible that the value of n can be greater than k, so you don't need to apply a binary search on n number of elements. You can apply only on k elements of the first array. This is your n and this much is your k. Only apply binary search on this much of part, don't apply on the entire array. Okay, so your h will be minimum of the array size and the value of k. So this is how you find the uh, this is the logic to find low and high. Is it clear, Anushri Tomar? Okay, so now if you haven't understood, I would suggest rewatch the explanation part. Okay, so this is how I'll apply low and I'll apply the binary search algorithm. So now let's write down the algorithm quickly and get this done. So basically, so let's write down the algorithm. So basically, first step will be to keep the array 1 as the smallest array. Just for simplicity, I will keep the array 1 as the smallest array. And now, what is the second step? So second step is to get the value of low and high. And we know low is what? Low is a maximum of 0 and m minus k. M is what? M is the size of the second array. Okay, and what will be the value of high? High will be a minimum of what? K and n. Is it making sense? I haven't got any reply from you guys. Just write down yes or no in the chat box if you have understood. Okay, so this is my low and high, and now I'll start applying the binary search. While low is lesser than or equal to high, I'll keep on applying the binary search. So first I will find cut 1, integer cut number 1. That is what? It is nothing but a middle element, low plus high divided by 2. This is completely clear, no? How to find cut number 1. And what will be the cut number 2? Cut number 2 is the difference of k and cut 1. We were doing right over here, right? C2 is k minus c1. This is what I have written. See, k will be lesser than the array size. Okay, let me explain. Just a minute. Let me reopen. Okay. K minus m or m minus k. What is the meaning of writing down, let's say, k minus m? So k minus m means remaining number of elements in the left partition. Left partition contains k number of elements, and let's say m number of elements are already present. How many elements are not present? That is k minus m elements are not present. Okay, this left partition size is equivalent to k. Already m number of elements are there. So how much of space is remaining? K minus m space is remaining in the left partition. Okay, got it? So this is k minus 1. Now this is what I have cut 1. So now let's try to find out L1, L2, R1 and R2. So what is L1, L2, R1, R2? So over here, as I mentioned, that low and high does not indicate indexes. They indicate the number of elements which I can include. So now over here, at this point in this array number 2, C1 was equal to 2. So your L1 will be C1 minus 1. And what will be R1? R1 will be C1 plus 1. Similarly, your C2 in this part in array number 1 was equivalent to 4. So what will be your L2? L2 will be equivalent to C2 minus 1, will be at the index C2 minus 1, and your R2 will be at index C2 plus 1. Okay, so now I can write down that my L1 is equivalent to array 1 inside my first array. At cut 1 minus 1, I will have my L1. What about L2? L2 is the part of array number 2. This is L2. L2 will be at C2 minus 1th index in the second array. That is cut 2 minus 1th index in the second array. Is it making sense? Yes or no? A quick +1 in the chat box. Pay proper attention. Yes or no? Now, what about the cut number 1? Now, what about R1 and R2? Will it be equivalent to C1 plus 1? Yes or no? See, over here, let's imagine the position of cut number 1. Let's take an array on this side. 4 1, and my low was equivalent to 0 and my high was equivalent to, let's say, is equivalent to 4. So that means your cut will be at this position. Now if you want to find R2, does R2 exist or not? In this case, this is my cut 1 and this is my array 1. Now let's say this is my cut 1 and my bid value somehow came out to be at this position. So do I have the value R2 or not? No, I don't have any value of R2. So in this kind of case, in this kind of corner case in which you are including the cut in such a way that all the elements of that array have been included, so you will not have R1 or R2, right? So if this is the case, that means if your cut 1 is equivalent to the size of the array, if your cut 1 is equivalent to the size of this array, then what does it mean? Then you have to include, basically, if this is the case, then your R1 should be equivalent to infinite. It should be equivalent to infinite. If your cut 1 is equivalent to n, then that means your R1 should be equivalent to infinite. And if your cut 1 is not equivalent to n, then that means the element present at cut 1 position is the element. So basically, over here, this C1 indicates 2, and that is the index of 0, 1, and 2, and that is the index of R1. So C1 already indicates the index of R2 and R1. C2 indicates the index of R2. C1 indicates the index of R1. Okay, so if your cut 1 is not equivalent to the length of the array, then your element R1 is present at the index cut 1. Okay, so if this is the condition, if this condition holds true, then you can return int max, that is the infinite. And if this is not the case, then your R1 is present at the index array of 1, cut 1 is the index. And what if cut 2 is equivalent to m? Similar to that over here as well. Array 2 and cut 2 is the index of R2. So now I have to handle this for L1 as well. Okay, yeah. Accidentally, I might have said that R1 is equal to C1 plus 1. Okay, yeah. Because I was focusing on the cut part, and cut already indicates its index. Okay. Similarly, for L1, there is a corner test case. Let me show you. For L1, let's imagine L1. L1 says 0. That means this cut. So for this cut, do you think L1 exists? If I am putting a cut over here, do you think L1 exists? Yes or no? L1 does not exist for cut is equal to 0. That means if I am placing a cut at the 0th position, that means 0 elements are included, then L1 does not exist. If L1 does not exist, then this comparison should hold true even though L1 does not exist. This comparison should hold true. So which element will be lesser than every other element? So minus infinite. So I'll keep L1 as minus infinite if cut 1 is equivalent to 0. Okay, if cut 1 is equivalent to 0, then I will put my L1 at index. I'll have my L1 as minus infinite. Okay, so one more addition on this part, that is, if your cut 1 is equivalent to 0, then your L1 is equivalent to int infinite, else it will be equivalent to cut1 minus 1. Similar to that over here as well. Now you guys might have been like, now you might have started. Okay, so now this is how you can handle this corner test case part. Now is it making sense what I was trying to say? Okay, so I already explained everything, every part about this algorithm, but over that, at that time, you were not able to see these steps. So that is the reason you might have got confused. Okay, so if now the condition, that is L1 is lesser than or equal to R2 and L2 is lesser than or equal to R1, then that means you have found your correct position for cut. Then in this position, at this position, just return the maximum of L1 and L2. Right? We were doing that over here. This part. If L1 is lesser than or equal to R2 and L2 is lesser than or equal to R2, then return max of L1 and L2. So that is what I have done. If this is not the case, else if L1 is lesser, if it is greater than R2, see over here, if, just a minute. So now over here, if L1 is greater than R2, then what I'll be doing? I'll be doing high is equal to cut1 minus 1. So what does it mean? If L1 is greater than R2, you can observe. Let's say if this was L1, if it is, let's say over here, this was L1 and this is your R2. If L1 is greater than R2. Let's take one different example. Okay, so let's say if this was L1 and this was your R2. So over here you can observe L1 is greater than R2. Right? This condition is not at all acceptable. So what I need to do? I need to decrease the value of L1 and I need to increase the value of R2. I need to increase the value of R2, then that means R2 should be placed at this position and L1 should be moving towards this direction. I repeat, L1 was 6 and R2 was 4. So basically L1 is greater than R2, right? So eventually I need a condition in which L1 should be lesser than or equal to R2. This is what I'm looking for with the help of binary search. So basically I need to decrease the value of L1, that is include less element from the array 1 in my left partition. So L1 will be pointing at 3 and R2 will be pointing at 8. I'm increasing the value of R2 and decreasing the value of L1. So that is the reason I will bring my cut. I'll include less number of elements from the first array. That is why I am doing high is equal to cut1 minus 1. That means decreasing the portion of array 1. Else the vice versa, that is low is equal to cut1 plus 1. And this is the entire binary search algorithm. Very simple. And at the end you can simply put the condition that return 1. Eventually you will find the answer at this in this only, but let's say, is it mentioned in the question what to do if you don't get the element, if you don't have the answer? Okay, nothing is mentioned. So eventually your task is to complete, and yeah, so every time you will, it is sure that you will be getting the answer. Okay, so this is how it is going to work. So was it clear? Was the algorithm clear till now? Yes or no in the chat box so that we can directly. Was it clear? Yes or no in the chat box, everyone? Okay, Pratik. So I think this algorithm is sufficient enough. You guys will be able to code this. So I'm not implementing it in coding because I need to share the other question as well because time is already running out. Okay. So I'm not showing you the coding implementation of this, but obviously this algorithm does not contain any fancy implementation in any of the language. So I will keep this implementation part on you guys. Implement this algorithm and get the solution accepted. At least I can accept this from my students, right? What should be marked as a hard problem? Yes, see, we were not aware about the standard problem, hence we are facing this kind of difficulty. As I mentioned, this is a variation of a standard problem. Okay. See, the more pressure you put on the standard problem, the more you will understand. So increase the pressure. Okay. So just focus properly on standard problems. Okay, Pratik. Okay, so I'll quickly share the question which I'll be giving you in homework, and just let's quickly go through the problem statement, and then let's end this session here only. So this is the question which I'll be giving you in homework. Okay, I've shared the link. You're welcome, Pratik, if you enjoyed the explanation part. Okay, so allocate minimum number of pages. This is one of the interview centric question, and this is also one of the standard problem. Okay, so you have n number of books, and each with ai number of pages. M students need to be allocated contiguous books, with each student getting at least one book. Okay, so M students needs to be allocated contiguous books, with each and every student getting at least one book. Out of all the permutation, the goal is to find the permutation where the student with most pages allocated to him gets the minimum number of pages out of all the possible permutations. Okay, and you can go through the example as well. So right now I'm not discussing this because the time is already running up and I don't want to make this session lengthy enough. So go through this question, and this is a very interesting question, and variation of this question and including this question has been asked in interview. Okay, if you will take any of the SD sheet, you will find out this question is present. And the last previous question, this the previous question is a like, what do you say, it is a variation of the standard question. Find the median of two sorted arrays. That question is also very interview centric question. Okay, so focus on that. Try to read down this problem statement and put down your solution in the comment section. Okay, I'll read down the solution. And for the previous session, I have not seen anyone. For the previous session, I have not seen anyone commenting down your solution. Okay, so be active on the stream, and you will enjoy the session and the stream as well. So that was it for today's session. I hope you really enjoyed this session, and if you really enjoyed this session, then do hit the like button and share it with your friends as well, right? And do not forget to comment down the solution for the last problem. Okay, so we're ending this session here only. Thank you everyone for joining. Bye bye. Have a good day and good night. Bye bye.